All right, close your eyes and imagine with me, if you will, that you've just finished a major router maintenance. You've just finished all of the upgrades you've needed. You've planned this for months. You got everything just right. And you jumped on the plane and you flew to Hawaii or Tahiti for that much needed vacation. You're ready to relax. Everything is great. You just finished your massage and you walk back into your hotel room relaxed as ever. And then you hear that sound. Your phone buzzing and vibrating. Oh, they took out all the animations. And just then you look at your phone and you see this. That string of text messages that all of us dread. Hey, Peter, I'm getting some weird alerts. Oh, crap, something's wrong. I need you right now. 48 missed calls. Answer your phone right now. Everything is on fire. The site is down. What did you do? How many of you have been in that position before? Raise your hand if you've ever walked out, gone home from work, and the router went down afterwards. For those of you who have never had that problem, please come talk to me. I would love to talk to you. I want to know what you're doing that I'm not. Well, that is our motivation and the impetus for the tool that we wrote during the hackathon yesterday called Takeoff. It's pre-flight validation and verification before bringing a router back into service, which Chris will talk about now.
Hi, I'm Chris. So we all have pre-flight checks. We bring a new router into production. Generally, if you're bringing a new device, you turn your routing protocols or cost them out. You do something to make sure this thing is online but not taking production traffic. Those pre-checks, those pre-flight tests, most of them are performed by human beings. You have a checklist. You log into the router, you run commands, you check the tables, make sure things look sane, interface is up, what have you. Why is this work being done by humans? Am I hitting the right? There we go. So what lessons can we take from, say, software development? Software development has continuous integration and unit testing. You make a change to a code, you run a standardized test harness, which runs through a set of standardized test modules and tells you if anything is amiss. Takeoff is that idea applied to operational state. So we built a test harness framework. Now I put the word unit testing in quotes here because I'm not using any of it. We're developing in Python, but we're not using any of the standard test case modules. I've heard this morning that one of our team members is actually working on doing exactly that. So hopefully next time we present this, there won't be any quotes there. So we developed a standard class signature, a superclass that a module that you would write would inherit from. So anyone can write their own modules and add them to a test suite. You can run the test standalone or as part of a automated device turnup. So you've got a script that hits your device and removes IS overload. You can have it load this module and execute the test runner immediately before that and stop if anything comes back false. Use it to augment your manual checks. Automate your final sanity checks immediately before. So if you tested it in the morning and things look cool, something broke between that time and your test window, hopefully this can help you catch that. So here's an example of what a sample test class looks like. There's a standard method signature, standard methods that get called based on the success or failure of the test you've written. And your test can do anything. It gets handed an SSH session to the device that you can execute commands on. You can compare router state to your offline source of truth, run ping tests, whatever you want to do here. So if one were to write a test, develop your code. Here's a YAML file that the test runner references to use standard Python class path syntax here to point it to your tests, and you can write device-specific tests or device non-specific tests. It'll run both the common and whatever platform you give it. There's a fake one in there too, just for testing. Get that in, and then run your test. You give it a platform name and a router name. It runs through the tests, reports what passed, reports what failed, get additional debug info if you like. Take the code and let's go.
So obviously, Chris and I are up here talking about this, but this was the work of a team. And the team was actually folks with varying levels of programming experience, from just beginning or just out of school to many decades worth. And I think one of the things that we really learned about this is that even in just 7 short hours, we could build something that was actually meaningful and could make our lives better. So if you haven't done this before, if you haven't programmed before, you should definitely join in and learn. Some ways you can do that: so you can join the NetEng code group on Facebook, the takeoff at NANOG group on Facebook, or you can download the code for this specific project on GitHub. It's proof of concept now, but we can keep making this better with help from people like you. And maybe, just maybe in the future, your next vacation won't be interrupted. Thank you. Thank you.